Now that we've defined Euler's method, let's look at a few examples on how to use this. I want to use a step size of 0.1 to approximate the solution to the initial value problem y prime equal to x squared of y, where y1 is equal to 4 at the points x equal to 1.1, 1.2, 1.3, 1.4, and 1.5. So let's remind ourselves what the actual formula is to find these values. The formula was that yn plus 1 is equal to y sub n plus h of f of xn yn. Well, let's go ahead and stick in what we know f to be, as well as what we know h to be. So this is yn plus 0.1 times xn square root yn. So let's start. Let's start with n equal to 0. So y of 0 plus 1, so y of 1. That would be the first thing we want. That's y of n, or y of 0, which in this case is just 4. That's given to us in the initial value problem. We then need to add 0.1 times xn square root of yn. So x0 and y0 are coming from the initial value problem, 1 and 4. So I have that y1 is equal to 4 plus 0.1 times 1 square root of 4, which gives me 4.2. So if x is equal to 1.1, y1 would be equal to 4.2. Now let's go to look at 1.2. So this time I need n equal to 1. And let's start sticking in what we know. So the formula says that we use the previous value for y, which is 4.2, plus h, which is 0.1, times the previous value for x, 1.1, square root the previous value for y, 4.2. We get approximately 4.42543. That would be our estimate for 1.2. To estimate 1.3, I would then use this formula. I would let xn be equal to 1.2 and yn be equal to this 4.42543, and I would be able to find my next value. If we were to continue this process on the last example to go ahead and get all of the values 1.1 through 1.5, here's what we would have gotten. We would need n to be between 0 and 5. We could then find xn. We could get our approximation, and then this last column tells you what the exact value actually is. And we can see that the further and further we get away from x being equal to 1, the farther and farther our approximation is from the exact value, although it is pretty close in this case. Let's look at one more example. We now want to find approximations to the solution of the initial value problem y prime equal to y, where y of 0 is equal to 1, at x equal to 1, taking 1, 2, 4, 8, and 16 steps. So let's start with the things that we know. Our initial condition gives us that our first point, x0, y0, is 0, 1. And our recursive formula for y says yn plus 1 is equal to yn, plus h times f of xn yn, which in this case is just yn. So I went ahead and simplified this to 1 plus h times yn. So if we want to take one step, then in that case our h value would just be 1. Since the distance between our initial point 0 and the point that we care about, x equal to 1, is 1. So then that gives us 1 plus h, which is 1, times y of 0, which is 1, would give us 2. What if we want 2 steps? In this case, h is equal to 1/2. So essentially the idea is the top of the fraction is the length of the interval. For us, we're going from x equal to 0 to x equal to 1. And the bottom is the number of steps that we want to take, in this case 2. In order to find this value, we have to start by finding y1, and then we need to find y2. We need to take 2 steps, so we're going to have to do this in 2 separate pieces. We'll start by finding the approximation for 1/2 and then move on to 1. y1 would then be 1 plus h, which is 0.5, times y0, which is 1. So that gives us 1.5. So y2 would then be 1 plus h, which is still 1 plus 0.5, times y1, the previous value that we got, 1.5, which gives us an estimate of 2.25. For n equal to 4, we would have h equal to 1/4, and we would need to find 4 steps. We would need to find y1, y2, y3, and then finally y4. For 8, we would need to do 8 steps, and 16, we would need to do 16 steps. So we won't do all of these, but let's look at what our approximations would have been. So here we have all of the values for n, which is the number of steps we wanted to take, the appropriate corresponding values for h, and then the approximations that we would have gotten. In the actual solution for this problem would be e to the x, since I'm really looking at y prime equal to y, so what function's derivative is itself. And then at the particular point 1, the actual solution to this is e. And so we see these approximations to e. And we can see what's happening here is the more and more steps that I take, the bigger that value of capital N is, the closer and closer the approximation is. And this shouldn't be super surprising. If we take smaller and smaller steps, we're going to get closer and closer to it. This is the core concept of calculus.